Hello dear students, I am Dr. Shikha Pandey, Associate Professor from Institute of Aeronautical Engineering. So today I will discuss about the vermicomposting systems. What are the systems involved in the vermicomposting process? So before, in the last lecture, I have explained you about the vermicomposting. So vermicomposting means the composting site by the use of some earthworm. So the earthworm can degrade the organic substance present in the solid waste, and in this way, by the degradation of earthworm, we'll get some useful material that is called as manure. So this is the whole vermicomposting process. It will involve the use of earthworm to degrade the solid waste or the organic matter present in the solid waste. Okay, so vermicomposting is a compost. We can say that now vermicomposting is a compost that is made up by feeding earthworms with biodegradable organic wastes. So biodegradable organic waste are there. So in that waste, we'll feed some earthworm, and that earthworm is going to degrade the waste, the organic matter present in the waste, and the earthworm digest these waste and excrete them. Then after, what this earthworm will do, they are going to digest all the organic matters present in the waste, and the excreta of the earthworm is called as the vermicompost. And this excreta is also called as worm casting. It contains water soluble nutrients and highly benefits for the plant and soil. So this vermicompost is a compost that is made up by the feeding earthworm into the organic waste. So organic waste are there. That waste is degraded by some earthworm, and with the degradation of this earthworm, the earthworm is excluding the excreta, and this excreta is called as worm casting. Excreta is called as worm casting. Worm casting. So that excreta is we can say that it is a water soluble nutrients. It will have water soluble nutrients. Water soluble nutrients are there that will be highly benefited to the plants and the soil. And the vermicast is again a new term will come. That term is called as vermicast. It is called as worm casting, worm humus, worm manure, or worm feces. So many words are there for this vermicast, vermicomposting. Either we can call it as a worm casting, worm humus, also worm manure, or worm feces. It is the end product of the breakdown of the organic matter by the earthworm. So it is this vermicast is the end product of the breakdown of organic matter by the earthworm. So that earthworm, what it will do, it will break down the organic matter present in the solid waste, and that breakdown of the organic matter they will eat, and they will exclude it from in the form of excreta. That excreta is called as vermicompost, and it is a very highly nutrient rich substance that can be used in the plants as a conditioner, or as a manure, also as a manure in the soil and as a conditioner in the soil. So this vermicompost is a very useful material, and it will be example of the conversion of resource from the waste. So the organic waste like kitchen waste, some canteen waste, hostel waste, or some restaurant waste are organic in nature. So those waste which is organic in nature will be put into the pile, and that pile will add some earthworm into the waste, and that earthworm is going to degrade the waste with the degradation of the waste they will excrete, and that excreta is called as worm casting, and it contains some water soluble nutrients that will be highly benefits to the plants and the soil. And this vermicast are there. This vermicast is called as worm casting, worm humus, and worm manure, and many names are there. All are the same thing, only the name is changed and the things are the same. And the earthworm is feed with the soil or some other organic waste, and the waste is get digested and excreted by them. So the earthworm is feed with the organic waste, means the organic waste is feeding by the earthworm, and that will be coming out, and this waste get digested and excreted by them. So that waste will be digested and excreted by them, and that excreta is a very useful thing that will be used as a nutrient, water soluble nutrients in the plants, and that will be having more benefits in the as a organic manure. Okay, so now comes to the next point. Here we'll discuss about the advantages of vermicompost. What does this vermicompost will do? What is the it's a benefit by adding into the agriculture field? So first thing is that it improves soil structure and soil texture. So with the adding the vermicompost into the soil, into the field, it is going to improve the structure of the soil and texture of the soil. Also improves the aeration of the soil. So aeration of the soil, aeration capacity will increase. In this way the soil will become more fertile. So it adds to the fertility of the soil. So fertility of the soil is increased. Fertility of the soil is increased and attracts deeply borrowed earthworm. Means which type of earthworm will be there? Because aeration will be there, so inside, so deeply borrowed earthworm that can degrade or that can enter into the deeply into the soil, so that because of the availability of aeration, the earthworm can enter into the deeply borrow of the soil and increases the water holding capacity. It is going to increases the water holding capacity of the manure or the organic compost. Next point is the free of weed, chemicals is there, and harmful pathogen. No chemicals is there when we are adding vermicompost into our field. So this, it will be free from chemicals, some harmful pathogens, some seed weeds will not come out, and it will be very easy to handle, apply and store. It is done means it will not having a bad smell. Also it can use as a soil conditioner, or sometimes it can be used as an amendment to the soil which is not good. Like some industrial soil is there, some soil are there which is present in the vicinity of an industrial industry, like soil that is present in the vicinity of thermal power plant. So in that soil some flies will be added. So what we'll do with that soil, you will add this type of vermicompost as a manure, as a conditioner into the soil, so that it will be added into the soil and act as a good nutrients, act as a soil amendment, act as a soil amendment. Okay, so these are the positive things like this vermicompost where it can be used. And also it encourages the population of useful soil microbes in the soil and increases the natural decomposition ability in the soil. So the natural decomposition ability in the soil is also increases by adding this vermicompost. So what does this vermicompost is do? This vermicompost is a very useful for the plants, very much useful for the plants also, crop also, and the soil also. It is going to improve the soil structure and texture. Soil aeration is also increased, and it attracts very deeply borrowed earthworms also. It will call deeply borrowed earthworm. So when we are adding this type of manures, automatically earthworm will come. So when the earthworm will automatically come to our field, they will degrade the organic waste, organic components, and excrete it as a vermicompost. And it is going to naturally increase the water holding capacity of the soil. In this way, the moisture content of the soil is increased, and it will be free from seaweeds, chemicals, and harmful pathogens, and it is very easy to handle, apply, and store, and it do not hold any bad smell. Means this vermicompost will not hold any bad smell, and it can be used as a soil conditioner or amendments. And it is going to increase the population of soil microbes in the soil. It will increases the useful soil microbes in the soil and increases the natural decomposition ability in the soil. Now comes to the next point. Here it is the mechanism of vermicomposting, means how this vermicomposting has been done. So first thing is the biodegradable material. Means biodegradable material means organic waste. Organic waste means those waste which is organic in nature, so it can go for the biodegradable. And next, what is the homogeneous mixture? This biodegradable material is make up as an homogeneous mixing. Homogeneous mixing will be there, like waste is mixed mixed and make the homogeneous mixture. So in that homogeneous mixture, now we will add, after that what we'll do, we'll add this homogeneous mixture to the vermicomposting process. It will be enters into the vermicomposting process. So in vermicomposting process, what happened? Some worms biomass will be added, oxygen will be added, H2O will be added. Okay, oxygen will provide due to for the aeration, for the proper functioning of earthworm. So in the we'll take the biodegradable waste and we'll make it a homogeneous mixture up to some ratio at one place, and we'll keep it inside a box, and inside the box worms will be added. Three things will be provided. First is the worms, second is the oxygen, and then water capacity. So these three things will be added into the vermicomposting process. Now the vermicomposting process will start. So this vermicomposting process will start, and two gases will come out from this, that is ammonia and carbon dioxide. So when the earthworm start degrading this biodegradable waste, two type of gases will be releasing from this vermicomposting process, that is ammonia and carbon dioxide. Then after what is there, where then again we are going to harvest this earthworm and cocoons with some worm biomass. And then what next step is the vermicomposting with living cultured soil microbes. So some vermicomposting will be some living cultured soil microbes will also there, so they will add it into the vermicompost. So earthworm cocoons harvesting is there, and after that vermicomposting is there, that is living cultured soil microbes. So this will represent the whole picture of a vermicomposting, how this vermicomposting mechanism take place. So it will start from the biodegradable material to its homogeneous mixing. Then after vermicomposting process will start. This is the main thing, where the vermicomposting process will start by adding worm biomass, by providing sufficient amount of oxygen, sufficient amount of water, and all these things will do degradation process inside the bin. Inside the bin, this degradation process will start, and if by this process two gases will be coming out, that is ammonia and carbon dioxide. So and after that, what in the vermicomposting process, what will happen then, earthworm and cocoons are there, and they will go for the harvesting process. And after the harvesting process, vermicomposting takes place with living cultured soil microbes. So and here it will be vermicast will come, vermicast or wormcast, whatever you can call by the name, and this is called as a vermicompost. So this vermicompost is the living cultured soil microbes that is coming out from the biodegradable materials of the solid waste. Okay, now what are the methods, which type of methods are following for the vermicomposting process? So the methods means the different methods are there, that is called as windrow methods, beds or bin, flow through reactors, trough, tower or pit or trenches can be described in the two type of systems. So basically windrow methods are there, beds or bins are there, flow through reactors are there. These are the methods. And troughs are there, tower, pit or trenches are there. And all these methods basically divided into the two types. First one is the batch system, and second is the continuous flow system. So in batch system, what happened, it is the one of the method in which bedding and food are mixed and the worms added, and nothing more is done until the process is complete. So in a batch system are there, in which beddings will be made, and in the bedding food are mixed and with the worms has been also added. So in the batch method, in the form of batch, this bio waste will be provided and the worms will be added and the foods are mixed, and the nothing more is done until the process is complete. So only will provide the bedding system, food are mixed, worms is added, and it will be done until the process is complete. Next is the continuous flow system. Continuous flow system are those systems in which worms are placed in adding, whereupon feed and new beddings are added incrementally on a regular basis. So continuous flow system in which what happened, the worms are placed in the, continuous flow system are there in which worms are placed in the bedding, whereupon feeds and new beddings are added incrementally on the regular basis. Means continuous flow has been provided while putting the worms at a place, and the feed and new beddings will be added incrementally on a regular basis. So these two methods are there already, I have explained. First one is the batch system and second is the continuous flow system. So in a batch system, only the bedding is provided and the food are mixed, worms are added, nothing more is done until the process is completed. And in the same continuous flow system, what happened? The continuous system are ones in which worms are placed, and then it will be feed and a new beddings are added incrementally. Means with the time new beddings will be added. That's why this name is there, continuous flow method. Means continuous some flow is provided, like with the time beddings will be provided and it is going to be added on the incrementally on the regular basis. So on the regular basis, this continuous flow system has been added, in which the worms are placed by adding upon, and feeding a new beddings are added incrementally on the regular basis. So basically two methods are there. Batch method, where beddings and food are mixed and worms are added. No extra incrementally process will be provided on the regular basis. Same thing is there in the continuous flow system. Here again what happened? Worms are placed in the bedding, where upon feed and new beddings are added incrementally on the regular basis. Next process is there, that is windrow wedge method. Like wedge is again some modified windrow methods. Beds are there and then continuous flow through the reactor. So in this what happened? In the windrow composting method, the feedstock is shredded, mixed and placed into a windrow along a non-permeable surface. So the windrow are turned on the regular basis to improve the oxygen content, distribute heat to regulate temperature, and to distribute moisture also. So in the windrow composting, the feedstock is shredded. Feedstock means the waste is shredded, mixed and placed into the windrow along a non-permeable surface. So it will be placed into the windrow along a non-permeable surfaces, and the windrows are turned on a regular basis basically. So these windrows has been turned so that the oxygen capacity will be improved and the heat will be distributed to regulate the temperature inside the bin, and the moisture contribution should be normal to normalize the moisture content and to regulate the temperature and distribute heat and improve the oxygen content inside the bin. So inside the bin what happened? The feedstock is shredded, mixed and placed, and this will be it will be act as a non-permeable surface, and the windrows are turned on a regular basis on a regular interval, and to improve the oxygen content, and it is going to distribute heat to regulate temperature and to contribute to distribute the moisture content of the waste also. Now we'll discuss about this windrow on a details. So these windrow composting methods are turned on a regular basis because only to improve the content of the oxygen, distribute the heat capacity, so that it will regulate the temperature and the moisture content. The heat capacity will be there, and due to at one place, if we will not segregate it, if we will not turn this waste on a daily basis, then what happen? Heat will be accumulated at one place, and that will be harmful to the earthworm. So that this windrow will be like at some temperature, at some time, it should be turned on the regular basis to basically improve the oxygen content, distribute heats and regulates temperature, and to distribute the moisture content also. The windrows are then turned multiple times during the composting process. That takes on average of 16 weeks depending upon the maturity requirement. So this windrow's total lifespan is the 16 week. So up to 16 week, these windrows are turned multiple times due to composting process, and it will be act as an average of 16 week depending upon the maturity requirement. So depending upon the maturity requirement, it can be turned out up to a 16 week. The last part of the process is it involves screening the compost to remove contaminants such as plastic and metals, and also grade the compost for the various end user. So the process basically improve the screening the compost to remove the contaminants like plastic and metals. So the contaminants are there in that composting site, in the composting bin. So it will be involve the screening the compost. Next point is the screening of compost. In this screening method, what we'll do, we will screen the compost like plastic and metals, and this is going to be it will be grade the compost for various end uses. Okay, and the oversized materials are there that is going to removed and can be put back through the whole process until they have composted down sufficiently. So this oversized materials are there that can also be removed and can be put back through the whole process until they have composted down sufficiently. So this will be involved whole process of the composting. Windrow composting. Windrow composting is nothing but the composting that involves the turning of waste up to 16 weeks, so that the moisture will not accumulate at one place, and the temperature should be regulated. So, and this process basically involves the screening the compost to remove the contaminants like plastic and metal. So the compost will be like screening the plastic or some contaminants will be there inside the compost. So the screening will be there, and that will be like grade the compost for various end uses. Oversized materials are also removed, can be put back through the whole process until they have composted down sufficiently. So the oversized materials are there, that material which is oversized. So this screening will be done for the plastic or some metals or some oversized materials. So for all these things, this screening process is there that is going to be filter out the extra materials, some plastic materials or some metals or some oversized materials, and it will be removed, can be put back through the whole process until they have composted it sufficiently. Okay, so this is the picture that is you can see that this is the windrow composting is there. You will see that the ground, this it is covered with the white color things. This is called as windrow composting. So it will be, this is the picture from the windrow vermicomposting, US American Resource Recovery, California. So in the 70 acres of land has been used for this vermicomposting process, in which 75,000 tons per year of the manures is coming. So manures or vermicast will be there, that will be like 75,000 tons per year we are getting. Tons per year of vermicast we are getting per year. This is the picture, real picture from the vermicomposting site of the US American Resource Recovery, California. Now next is the static pile windrow, that is called as batch type. In the batch type, that windrow has been put. Next is the top feed windrow, like continuous flow. Wedge type of vermicomposting. Wedge is like, it is again comes under for the continuous flow. Beds or bin vermicomposting, top feeds vermicomposting, stacked bin vermicomposting. So static piles is the batch type. We will add these things in a batch type mode, and it will be put on the big ground or inside the vermicompost bin. Top feed windrows are like the windrow which will be having a continuous flow. Continuous flow means like it will be provided on time to time basis to the top feed windrows. Wedges are there. In the wedges we'll provide, here again in the wedges it is continuous flow, because after every week we'll do turning of the waste, or will not be able to the, it should be not means more moisture to be accumulated or no heat should be gathered at one place. That's why this continuous flow is there. Next is again in the beds or bins is there. So this type of beds are there. Beds are there. In the beds or like this bins are there like this. This can be used for the vermicomposting process. Okay. Next is the stacked bins. It will be formed in the form of batch or continuous flow. Batch type is that type of vermicomposting process where the static pile windrows are simply piles of mixed bedding and feed or bedding with a feet layered on the top that are inculcated with worms and allowed to stand until the processing is complete. So in the static pile windrow, all are simply mixed bedding and feed and that are inculcated with worms and allowed to stand until the processing is complete. These piles are usually elongated in a windrow style but can also be square, rectangle, or any other shape that makes sense for the person building them. So these piles are usually elongated in a windrow style. It has been elongated in a windrow style, but it can be like in a different shape will be there, like in a square, rectangular, or triangle, and it will be making sense for the person building them. Next is the care must be taken to provide good environment for the worms. Obviously, the worms care is very much required because the good environment is required, and the selection of bedding types and amount is also important. So this is the specification about the batch type vermicomposting, in which we should provide a good environment for the worms, or the selection of bedding types and amount is important. Okay. Next, we'll discuss about the continuous flow vermicomposting. So the top feed windrows are similar to the batch type, except that they are not mixed and placed as a batch, but are set up as a continuous and flow operation. So the top feed windrows are very much similar to the batch type, except that they are not mixed and placed in a batch. Means here what we'll do, it will be not mixed and placed in a batch, but are set up as a continuous flow operation. This means that the beddings is placed first, that inculcated with worms, and then covered repeatedly with thin a layer of food. So the bedding is placed first, then inculcated with worms. Then we'll add some worms on the layers, and then it will be covered with the thin or layers of food. And the worms tends to consume the food at the food bedding interface, then drop their casting near the bottom of the windrow. So what happened? These worms will be consume the food at the food bedding interface, and then it is going to drop their casting near the bottom of the windrow. And a layered windrow is created over time with a finished product on the bottom, partially consumed bedding in the middle, and the fresher food on the top. So a layer windrow is there. That windrow is created over time with a finished product on the bottom. Means on the bottom the finished product will be there, means the product which will be completed, and partially consumed, it has been partially consumed the bedding in the middle and the fresher food on the top. So this will be like a continuous top flow of vermicomposting. Next is the vermicomposting in the bins. So the simplest form of vermicomposting involves a bin made from plastic or untreated or non-aromatic woods. So this is like it will be made up by some bins, and that bins has been made by some plastic or non-aromatic wood, and some forms of beddings like shredded paper, composted animal manure, or decaying leaves fills the bin and mixed with a few handful of soil to provide the worms with material through which to burrow. So some forms of bedding will be there, like some shredded paper, composted animal manure, decaying leaves fills the bins and mixes with a few handfuls of soil to provide the worms with material through which to burrow. And the bedding also require water to stay moisture and allow the worms to breathe. This bedding will be like that. It will be require some water. That water will keep it to stay moist and allow the earthworms to breathe, and the feed the organic food scrap like vegetable, fruits, tea bags, and coffee ground. So this will be feed the warm organic food scrap like vegetable, fruits, tea bags, coffee ground. So this is all about the bin type of vermicomposting. Bin type of vermicomposting is basically a bin is there that is made up of plastic or some untreated or non-aromatic woods, and the some forms of beddings will be there like shredded paper, composted animal manure, or decaying leaves fills the bin and mixes with a few handfuls of soil to provide the worm with material through which it has to be burrow. And it will be required water to stay moist and allow the worms to breathe, and feed the worm organic food scraps such as the vegetable, fruit, tea, coffee grounds are there. So you can see that this is the picture of vermicomposting methods. This will be like bins. Here I have already explained that bins will be there. Inside the bin we'll keep the solid waste, we'll keep the waste material, we'll keep the earthworm, and we'll provide everything. This is a picture of a windrow. In the windrow, composting is there. See, this is the picture of the windrow composting. In the windrow method, the composting is carried out like windrow composting method and bins composting method. Next is the vermi wash. Vermi wash means a liquid that is collected after the passage of water through a column of worms action and is very useful as a foliar spray. So the vermi wash is that type of liquid that is mostly collected when the passage of water through the column of worms, means the water that will be collected below the column of the worms, and it is very much useful as a foliar spray. It is a collection of excretory product and mucus secretion of earthworm along with micronutrients from the soil organic molecule. So what happened? The passage of water through a column of worms action, and it is very much useful as a foliar spray, and it will be collected. The collection of excretory products and mucus secretion of earthworm along with micronutrients, means it is a collection of excretory products, mucus secretion of earthworms along with the micronutrients from the soil organic molecule. These are the transported to the leaf, shoot and other parts of the plant in the natural ecosystem. In the natural ecosystem, these vermi wash can be transported to the either leaf, shoot and other parts of the plant to provide the nutrients to the plant, because vermi wash is a liquid that will be collected through this during this process. So this is also a very highly nutrient things. So when it will be transported to the leaf, shoot and other part of the plant in the natural ecosystem, and it has been reported to have an excellent growth promoting effects, and besides serving as biopesticide. So it will be like, obviously it is a very good growth promoting effects, and it will be besides serving as a biopesticide. It's not a biopesticide. It will be having a very excellent, it will be providing very excellent growth to the plant. So instead of using the biopesticides, this vermi wash can be used for the plants to increase its growth, for getting excellent growth in the leaf, shoot and other parts of the plant in the natural ecosystem. Okay, so this is like, now I am going to, this will be a conclusion of this vermicomposting methods. So in this vermicomposting methods, I have explained that vermicomposting is an alternative method for the waste management through which vermicompost is produced with relatively high nutrient contents than compost and manure. So it is like a alternative methods for the waste management process. So this vermicomposting is an alternate method for the waste management through which vermicompost is produced with relatively high nutrients content than compost and the manures, and it will be having a good method for the waste management, and it can be used to shift from chemical fertilizers to reduces the hazardous effects of chemicals to both crop and human being. So it will be like, it will be used as instead of chemical fertilizers, this vermicompost can be used instead of chemical fertilizer, and it is going to reduces the hazardous effect of chemicals, and the application of vermicompost either alone or in combination with some fertilizers, it is going to promote the crop yield. So this vermicomposting, in this way we can say that with this vermicomposting is a very good method for the waste management through which vermicomposting is produced with a relatively high nutrient content than the compost and other material, and it can be used to shift from the chemical fertilizer to reduces the hazardous effect. Obviously it can be used as an alternate to the chemical fertilizers, so that it is going to reduces the hazardous effects of chemical in the crops and human beings, because when we are using the chemicals nowadays we are using some fertilizers with some chemicals, so these fertilizers is going to reduces is very much dangerous, and that's why this if we are going to use this type of manure, this will be very much environment friendly too. And the vermicomposting, it can be used with some fertilizer, or it can be alone used. So what does it do? It improves the soil physical condition, that supports the better aeration to plant root, drainage of water, facilitation of cation exchange, sustained availability of nutrients, and thereby the uptake of plants by resulting in better growth. So it's a positive effect of using this vermicompost is like physical. It will improve the physical condition of soil, like it increases for the better aeration of plant root, drainage of water system, facilitation of cation exchange capacity, sustained availability of nutrients, and thereby the uptake by the plants, resulting in the better growth of a plant. So in this way we can see that this vermicomposting is a very useful thing, that it is going to increases the growth of the plant by in terms of the better growth also. And the drainage of water, like facilitation of cation exchange, sustained availability of nutrient, thereby the uptake of the plants, resulting in the better growth. So these are the references of some of the textbook that I have followed for this lectures. For this, if you want to go in the deep of this lecture, you can follow this textbook. These are the references. You can go for this textbook. You will be find some more deep knowledge about this vermicomposting process. And so here I'm going to conclude my lecture. In this lecture, I have explained you about the vermicomposting system, and how windrows, stack piles, continuous flow, all type of system has been used, and on a large scale. And if you have any query, if you have any question regarding this lecture, you can mail me on the my given mail id, shikha.pandey@gmail.com. And for now I'm going to conclude this lecture. So thank you for today's lecture.
Like, share, and subscribe. Hit the bell icon for more updates.